And the last topic we're going to look at in this section is we're going to talk about what it means to factor completely. And just kind of simply put, when we are asked to factor, right, we need to get something in its simplest factor. So when we say factoring completely, it cannot have a GCF remaining. When we have our factors, we have our products written down. If a product has something in common, if they have a factor in common with each other, we say that it's not factored completely, and there's another step that needs to happen. Maybe, kind of just a quick example. If we look at something like this, right? Well, this factor of 2x plus 4, we should see that, we've talked about finding GCF of values, and we've talked about factoring for a while now, that, 2 and 4 both have a common factor with each other. These guys are not relatively prime of each other. 2 and 4 both have a value of 2 that can go into them. So we've talked about what it means to factor out a GCF. So this is really, in essence, what we're doing. Just making an emphasis on, make sure we are looking at this when we're factoring. So if I pull this 2 out, if I pull the 2 out of 2, right, 2 divided by 2 is 1. 4 divided by 2 is 2. This is what the factors are now going to look like. When an expression has a GCF in common, right, this number is going to be hanging out, and then we have the other factors that are going to be in parentheses. And notice that the numbers that we have here are 1 and 2, and then 1 and 5. Those lumps of numbers are relatively prime of each other. They have nothing in common. We know we are factored completely. So as we get going, some of the things to look out for. You're not hindered to just these 4, but these are usually the 4 main things that when a test or an assessment asks you to factor, these are some things that they kind of throw at you here. So one thing to refer to is the A value. So remember, the A value is the coefficient of the x squared. When that isn't 1, I would always look to see if that's a number that I could pull out, right? Because when factoring, when the A value is 1, it makes everything so much easier to factor, right? When the A value is larger than 1, there's a whole, other process that's involved. So the first thing that I would do is I would try to look to make, the A value 1. In this particular case, the coefficients, or our A, B, C values, are 2, 10, and negative 8. Well, 2, 10, and negative 8 does have a GCF larger than 1, right? They all have a GCF of 2. And in doing so, right, I identified that the A value is a 2. I can go ahead and pull that factor out. So if I cut everything through by 2, that's going to leave me with x squared plus 5x minus 4. Okay, now here in a little bit, when we're talking about factoring completely, we're going to have to factor this as well. Okay, but right now, I'm just showing you kind of things to kind of look out for. So first thing, definitely, if you can make the A value 1, I would look to make the A value 1. Another thing to maybe look out for, what if the numbers are really large, right? You don't want to sit there and factor in this particular case. Maybe having to multiply 100 by 2400, right? This is a dead giveaway of, an assessment making you aware of, hey, we can cut this, by 100, right? They all have these 2 zeros in common. So what I'm going to do is I'm going to factor out, or I'm going to divide this factor of 100 away from all of my terms. So if I divide everything through by 100, again, this 100 needs to stay along for the ride. It's still a factor. It's still part of your expression. But what we're left with, 500 over 100 is 5. And then 2400 over 100 is 24. Now, this guy here looks so much easier to factor than us dealing with those values in the hundreds. Another thing to look out for is when the A value is a negative. So again, the A value stuck to the x squared. If that's a negative, you're going to want to get rid of that, okay? It becomes a lot easier to factor once that A value is a positive. And the way we do that, so I don't want this negative here, and the coefficient here is a negative 1. So what we can do is we can pull out a factor of a negative 1. Okay, and look what that does. Again, that negative 1 is going to be along for the ride. And what that's going to do is pretty much change the signs of all of the terms in my expression, right? So I have a negative over a negative, that's going to be a positive. I have a positive or a negative, that's now a negative. And I have a negative over a negative, which makes it a positive. Okay, so again, we pulled out this -1, but now look at my A value. My A value is a positive. Now we can get into using our box or a diamond and being able to factor, okay? But like I said, you know, life becomes a lot more challenging when we're having to factor, we're having to deal with an A value of a negative. One other thing to look out for is what happens if we're dealing with more than one variable, right? We have x squared y, we have xy, we have some y's. I would look to see if there's something that's in common of all the terms to see if there's a way to get rid of these variables, right? It's hard enough factoring when we have one variable. You know, when two comes into play, it definitely gets a lot harder. So see if there's a way we can factor it out. Well, there's a y here, there's a y here, there's a y there, right? So what I can do is, again, once I notice that it's in common of all of my terms, we can, again, factor it out. So when I pull this y out of all three of my terms, I'm left with x squared minus 5x plus 6. This now looks like your typical quadratic that we've been factoring for a while now. We can go ahead and proceed with that. But here, you know, things definitely would get a little bit more interesting, way more difficult. Okay, so not saying every example that you have is going to have one of these four things in common. You know, you're still going to be exposed to the quadratics that we have seen, but just some things to kind of look out for to maybe make your life a little bit easier, being able to identify those GCFs. So let's go ahead. I've got 4 examples where we need to factor completely. And remember, factoring completely, we can't have factors that have other factors in common, right? They have to be relatively prime of each other. So here we go. So our first example here, 3x squared plus 9x minus 12. I recognize my coefficients 3, 9, and 12 have a GCF of 3. So what I'm going to do, I'm going to knock down these numbers, and actually in doing so, I now make my A value 1. So I have x squared plus 3x minus 4. Now that my A value is 1, I can jump straight into the diamond, and it looks like 4 and -1. So remember when we are factoring completely that 3, why we're blurry. That 3 is still a factor, so he needs to stay along for the ride there, and then I'm going to fill in what I have in my diamond. This entire thing. Remember, we take a sum to a product. If I were to distribute and multiply this all the way back out, I would end up right back to where I left off. Cool. 3 more examples. Again, these numbers are relatively large. I'm going to see if there's any way I can to knock down these things the best that I can. The GCF of all of these hundreds, 100, 200, 300, you should be able to see. Let's go ahead and knock this down by the hundreds. Again, I'm going to pull that 100 out. He's still involved in our expression, but now I'm left with x squared minus 2x minus 3. Even now, again, remember, see, look, that our A value is now 1. This becomes a lot simpler to now factor. So 1 multiplies to get -3, adds to get -2, -3, +1. So when I go to write my factors, the completely factored form of this quadratic is 100 times x minus 3, x plus 1. Another example. Again, here we should notice that the A value is a negative. I'm not saying you can't factor. All of these things were factorable without doing this first step, but it definitely makes life a lot more difficult, and you have to factor it in the end anyway because you are always asked to factor completely. So what I'm going to do here is I'm going to pull out this factor of -1. I have this -1, and doing so, it pretty much is just going to flip the signs. The -4 now becomes a +4. The +21 now becomes a -21. All right, again, this makes my A value 1. I'm just making easier examples. This isn't always going to be the case. Just because you factor out something doesn't mean your A value is going to be 1. You could still end up with an A value larger than 1. But I'm trying to keep these examples more simple for you so we don't have to go through all that again. So what multiplies to get negative 21 adds to get positive 4. I think we're dealing with 7 and negative 3. Again, the negative 1 needs to be represented there. We have x plus 7, x minus 3. Again, here are now we have 3 factors, but make sure they are all represented. And lastly here, this looks like a big mess, but again, the harder it or the more intimidating it looks, always look to see if there's something you can pull out to make life a little easier for you. Well, looking at my 3 terms, 2, 12, and 10, we should first recognize that all 3 terms have an even. So I can cut them in half, right? Let's pull that even out of them. But also, we should have 2 variables. I've got a y squared, and a y squared. They all have a y squared in common. So what I'm going to do, identifying that greatest common factor, since they all have it in common, I'm going to pull it out of them, okay? Now, I'm going to divide everything through by 2y squared. I'm going to go ahead and copy that back down. And that's going to leave me with x squared plus 6x, plus 5. Right? 12 divided by 2 is 6. X, there's nothing we can do there, so that's copying down. Y squared over y squared is going to go away. 10 divided by 2 is 5. Y squared over y squared is going to go away. Now, again, this 2y squared is along for the ride. Now I've got a quadratic hanging out in here that has an a value of 1. So all I need is the diamond. 5 goes up, 6 goes down. What multiplies to get 5 adds to get 6. Well, 1 times 5 is 5, and 5 plus 1 is 6. So now, in order to write my factors, the 2y squared is still part of it, but now I have these 2 factors of x plus 1 and x plus 5. All right, so hopefully your skills of factoring are pretty sharp, right? Either, recognizing if the a value is 1 or the a value is larger than 1. Do we use the diamond or do we need the box and the diamond? But now, being able to factor completely. These are 4 cases, 4 different scenarios that could possibly happen that is going to force you to, pull out a GCF from the beginning. Now that you're kind of cognitive of it, that is the first thing you should always look for. When you see a quadratic and you're asked to factor, the first thing you should look for, is there something that I can pull out, okay? Whether it be to make the a value a 1, whether it be the numbers are really large. I don't want to factor that big quadratic. I want something smaller to handle. Is the a value a negative? Are there a lot of variables, okay? So just kind of being now more aware, more cognitive of, hey, I need to make this a little bit easier on myself. If they have a factor in common, I need to start looking for those common factors.